So thank you for coming. Did a talk last year, 90-minute talk with the same title, hence this is ongoing. Not going to cover anything I covered there. Here's my contact details. The picture in the background is relevant because, as I was telling my friend Seb, my passion is salmon fishing, and if you work at a place near a salmon river and you offer me some work in the salmon season, I will offer a significant discount on my rate. Seriously. No, not at all. That's the River Tay, if you're interested. So, going to talk about cyber-dojo. The word dojo is a Japanese word. It's literally the physical building where martial artists practice their martial art. Seems to be scratching an itch. It's fairly popular. It's evolving. As Björn Strustrup said, there's two kinds of code bases, those that people complain about and those that nobody uses. It's run in a non-profit way. So when you use the site, you're encouraged to make a donation. It's completely open source, though. All the money goes towards buying Raspberry Pis for kids, which get posted to various places in the world. I therefore get some interesting challenges in terms of bureaucracy and getting stuff through customs and things like that. There's some problems getting them through Nepal at the moment. But it is 100% of the money goes towards charity because the hosting is paid for very generously by Cucumber. The site is the GitHub site is an organization, and within the organization there's a repo for each of the services. So this was last year. It had just started to become not a monolith, and you didn't have to install Ruby, etc., on the server if you wanted to run your own cyber-dojo. You simply had to install Docker, which is easy, and then that was pretty much it. There was one script to install, and it ran. So I've been decoupling because I'd like ultimately to be able to maybe move this away from Rails. It's slightly more heavyweight than I need, and the threading here isn't required anymore because of the Nginx. So these are the new services that I've been working on. I'm pretty happy with that, so I've been moving on from that to the build architecture, because once we have separate repos for each of the separate services, things happen. So the situation at the moment is that if you make a git push to a particular Git repository, this one's the runner that actually does the 10-second timed out run, Git notifies Travis, and Travis goes through a script which we'll very briefly look at later, shortly, creates an image, and if all the tests successfully pass on that image is pushed to the Docker Hub. If you're not familiar with this is effectively just like GitHub, but rather than storing source, it stores runnable Docker images. Travis also then notifies any dependent repos. Yeah, and there's a chain of dependency, as there always is, and this can ripple through, and ripple through. And it works, it's good enough for now, but there's a significant problem with this, which is the next thing I'm going to address. Can anyone see what it is? Excellent. Yeah, you can imagine a situation where you commit some code here. This works. This is pushed to the Docker Hub. This becomes the latest image, therefore, by default. The notification happens here because this is a dependent repo. Some of the tests in here pull this image. Only a couple of them in the smoke tests. Most of them are unit tests. We come through to here, and this fails. This doesn't happen, but now we have an inconsistent set of images. So it's just the usual story. Number of ways you can solve this. This is the way I'm planning to do it, where we just use the hash on the git push over here when you do a commit, and that becomes part of the tag name on the image. Yeah, and on the very last step in the dependency chain, which has accidentally been left off here, we have a repo that's just the top-level system tests. And again, this creates an image. All those tests run, and if they all pass, not only do we push the test repo with the image, I should say, we also then tag all of the particular images that have been pushed to be the latest, and then we therefore get a consistent set which become the latest. So standard kind of stuff. But there are other options. This is another option. We could move everything to a single Git repository with Git submodules, And there are potentially significant advantages with that, not least of which is that if you are a developer wanting to help contribute to cyber-dojo, for example, this is much, much easier for you to get up and running. But that's quite a long way from this, so this is obviously going to be the next step. But it'll have to wait until a couple of weeks, because next week I'm doing a week salmon fishing on the River Spey. Quick look at what happens in Travis, as I said. Git over here notifies Travis. Travis then pulls the particular repo in question. It builds an image, and the source for whatever it is and the tests for that get built inside the image. There's a number of ways of doing this, and they always have trade-offs, of course. But what I don't do here is build an image without the source and then volume mount the source. That would be much faster on a slow local loop, but I don't do that for various reasons. Not least of which is that when I want to run the tests, I want those tests to be run in a way that's as close to the way that the thing is actually deployed at the end. So I build my image with the source and the tests inside it. I then spin up, or I don't, a script build does it. It runs the container from the image. It shells into the container, and then it runs those tests that are inside that container, which of course is exactly the way it's actually going to be run on the live server. And if all of those tests pass, the script finishes, we kill the shell, kill the container, we've got an image that, as far as we can tell, is okay, and then we push that image to the Docker Hub. I'm very keen on testing, so expanding a little bit on the testing, when I'm testing the actual code here, this is just the first step, and if everything passes here, I then have a second step, which is a very small pretend client that's consuming the service that this particular, whatever it might be, in this case it's the runner, is exporting. So this is the HTTP service on the inside, and this is consuming the HTTP service through gets and posts, because again, I want this to be as good as I can make it. I think this has proved very valuable on many occasions. I'm going to talk a little bit about something here that I find interesting, some surprises that you might find interesting too. One of the things I like about Dojo is that it's my playground, so I can do stuff out and try stuff out. And because I've had it from the beginning, I've been able to keep it at 100% coverage all the time. It's difficult to get to 100% if you're not 100%, but if you're at 100%, it's quite easy to stay there. So this, again, is a meta test. There's several meta tests here, but this particular one is the fact that we have to have 100% coverage of the source, but we also have to have 100% coverage of the tests. Someone suggested that one time. It's easy to write a test and for some reason it's not called or something like that. Okay, so we have to have 100% coverage like that. Otherwise, the test fails and you don't get an image and it doesn't get pushed. Big plus for 100% coverage is refactoring. You can do it with tremendous confidence. So on the GitHub repo, there's 10,000 commits for cyber-dojo, and I just did a quick little bit of bashing to find out how many of those commits were refactoring, and pretty much 25%. I love refactoring. Another reason that I really like 100% design is not because of the 100%ness, it's because of the 1% when you get to 99. It's what it shows missing that is very valuable. So here's just an example I've pulled out. This is a call to sleep, obviously. When I want to remove a container, I issue the magic incantation, and I can stub this very easily so that removed is whatever value I choose to make it, and I can therefore force sleep to be run or not as I choose. But of course, choosing to make it actually run is not great in this case because it's asleep, and it's going to slow your tests down. It'd be nicer if we could, in this case, stub that one out as well. This is not the way to do it. Yeah, just to quickly go back. This is on one line, this is on the previous line. We're looking for statement coverage, line coverage. So if we cheat by putting them both on the same line, the coverage tool is fooled into thinking we've got 100% coverage, and we do, but we haven't actually solved the problem. So what is this telling us? Any thoughts? Clearly not. It's telling me I've got different levels of abstraction. Why am I making a call here, which is a shell call, using my own mechanism that I can stub out very easily on a seam, and yet here I'm calling a sleep directly through the Ruby library? Yeah, this is what it's telling me. And so we very, very simply switch to doing assert exec like we did there to here. So I find this a really powerful guideline when I'm coding, that when you have things at different levels of abstraction in the code and in the tests, it can be a warning sign. Another thing that's really tremendously valuable with 100% coverage is that you can delete dead code really with great confidence that it is dead. And if I hadn't have done this exercise, I wouldn't have believed how often you get code that is dead that you wouldn't have otherwise spotted unless you had 100% coverage. It is really, really quite remarkable in my experience. But there is a trap. Quite a few occasions I've ended up with this situation here, where I had dead code that nevertheless is covered by tests, because everything is tested one way or the other, and there's low-level unit tests that test at this level, higher-level tests that maybe that test here, but there's no connection between here and here. Right? We've got an isolated piece of code that is being kept alive by tests, and they're the only clients that are ever using it. So in this situation, what I very quickly discovered was I need to have a mechanism of choosing my tests very precisely. If I want to pick out 4 specific tests here that I have tremendous confidence will give me the coverage, if it exists, into this piece of code, then I need some way of naming my tests. And I looked at the way it was done in the library, the test library I was using at the time, and I wasn't satisfied with it. You had to put the line number of the file and all kinds of stuff like this in some cases. It was painful. So I came up with a tiny little adapter that just uses hexadecimal notation. And I label each test with a hex. And I label the class, which is a test class, with the hex. And I label the whole module with a hex identifier as well. And they all chain together, and you can choose the level of granularity that you want to pick. So in this case, if we quickly go through it, we can see the default is you run everything. That takes a long time, obviously. But if we choose the hex ID, which is the one for the whole test, we get all of the tests, including the ones we can't see. Fewer number of assertions, it's quicker. Or we can choose the granularity. So this one's the other end of the scale. This is precise, just one test, had 3 assertions in it. Or we can do things like pick B3, and you can sort of very crudely, arguably, you can specify some kind of relationship between these without having to do some kind of nested composing kind of structure. I use it, I find it works for me. I really, truly value the ability to jump between the levels. I'm doing some unit tests, everything's fast, and then I find perhaps there's a fault in some higher level test, which isn't the unit test. I have to go back to that level. I want to pick what I'm running when I'm running it. Ruby's tremendously flexible like this, so this is just a quick look at how it works. Yeah. I can have the if here, which is looking at the values that are passed in on the hex. Yeah. And if everything works out and this is a test which I've said, yes, I want to run this test, then that is actually the point when I actually get the method. Before that, it wasn't a method. It has to be defined as a method using the reflection capabilities of Ruby, which are obviously very good because it's a very, very dynamic language. Thank you. Once I pushed on that idea of recognizing that relying on the default test framework that you've got and not having any malleability, not being able to change that test framework, I really quickly realized that's a really important thing. If you can't easily modify the test framework that you've got and bend it to your will, that is, for me, that's really quite a severe thing nowadays. So here's a quick example. In cyber-dojo, there are some tests that run code, and sometimes the image for the language in question is an Alpine-based image, which is very small, and that's nice, and sometimes it's a Ubuntu-based image, and that's very large, and that's not so nice. Well, I need to test both of them. I don't care which language you pick, which is Alpine, and I don't care which language you pick, which is Ubuntu, but I want one of each, and I want to literally run the same test twice, but I don't want to write the same test out twice manually. Yep, so it suggests the duplication and the repetition suggest another level of abstraction. So I create an operating system test, which all it does is run the same test that you provide, which is this one, which is not relevant, and it runs it once as an Alpine test and once as an Ubuntu test. Again, details aren't particularly important. The most important thing is the chaining. This is my adapter, which ultimately goes down to test unit in Ruby, and this is my next level adapter, which ultimately chains back to the one we just saw. And you can build this up and build it up and do whatever you like. That's just out of interest. That's the test that we are actually running, checking that files exist in the right place and have the right user and the right group and they're the right size, etc. Also doing monitoring. This was something I added with my friend Mike Long. This is a typical kind of day, non-weekend day. We typically get about 1,000 plus test events per day on cyber-dojo at the moment, where each test is literally you hitting the test button once. Okay? So that's all I had to say. Any questions? Oh, hang on. Yeah.
The TestNG people have been doing that sort of test slicing,
Right.
literally using XML to define suites rather than, so they do tag all the text.
Right.
Was there somewhere that you got the idea from, or in this form you generated it yourself?
There was a couple of things that sort of came together, as always is always the case. If we flick back very quickly, whoops, not to that one, to this one, then something I didn't like about the sort of fairly crude at this point in the history way that the Ruby test framework that I was building on was that you had to name your test using the old-fashioned JUnit. The name of the test literally had to begin with test underscore. Yeah? And remember the 60-column limit that we talked about on my keynote? You know, if there's one place where you want a long identifier, it's the name of your test, right? So again, I abandoned that, and this is literally my test name. If you don't know the Ruby syntax, this is a way of saying I've got an array of strings separated by words, and it just does the job for you. Under the hood, I concatenate them back together with spaces between them to generate the name of the test. But I can have the name of my test as long as I like, and I can split it across as many lines as I like without having to fart around with double quotes and commas to separate them and all this kind of rubbish, okay? So that was one of the reasons I did it. Once you've got your foot in the door and you've got something, you very quickly see other things building on top of it, of course, okay? But that is the syntax I now have for my way of writing tests. Okay? Yeah. Who here's used cyber-dojo? Fair few. Cool. If you haven't, urge you to give it a try. It's all in a good cause. We're going to put Elm on shortly. My friend Austin has promised to help me put Elm on, because I don't know Elm. And often the hardest part is writing the first test. Second hardest part is often installing the damn thing, because a lot of the installers are GUI. The only way you can install the thing is with a GUI, and I need to script it in a Docker file. So that can be a challenge sometimes. Okay, thanks a lot.